Hello everyone, my name is Abhishek Kumar and I am a research scholar at the Center for Compressor Technology at City St George's, University of London. Welcome to this week's Tuesday lecture where we'll be discussing multi-stage screw compressors. To understand multi-stage screw compressors, we first need to look at the air compressor market. As you can see from the histogram on the left, the compound annual growth rate of the global air compressor market is about 3.5% from 2022 to 2030. However, the global air screw compressor market is expected to grow at a CAGR of approximately 6.5%. With this rapid growth, it's essential to develop products that are low in carbon emissions and sustainable. If you examine the life cycle plot on the right, you will notice that operational costs, primarily due to energy consumption, constitute a significant portion of the total cost, leading to carbon emissions. Therefore, optimizing screw compressors, either through individual parameter optimization or multi-stage compression, is crucial. Talking about the multi-stage compression, it is basically associated with piston compressors. If you look at this indicator diagram of a two-stage compressor, the pressure rises from P1 to final P2 with an intermediate pressure Pm. This diagram illustrates the compression process in two stages. Starting from the initial pressure P1 at volume V, the gas is compressed in the first stage to the intermediate pressure Pm. After passing through an intercooler, the gas temperature is reduced before entering the second stage, where it is further compressed to the final pressure P2. Intercooling between stages lowers the gas temperature, reducing the gas volume at the start of the second stage and making the process more efficient. This cooling process reduces the area under the curve in the PV diagram, indicating reduced work during compression. This is why multi-staging is favored for work reduction. The figure on the right shows a two-stage compressor driven by a bull gear with the first stage as the low pressure stage and the second as the high pressure stage. These stages are connected by an intermediate pipe, channeling the discharge from the first stage to the suction of the second stage. This is the typical configuration of a two-stage screw compressor. Multi-staging has various applications, particularly in high-pressure scenarios such as oil and gas exploration, fuel gas boosters, mining, well sinking, pet industry, and pipeline services. However, it's important to explore both the design benefits and limitations of multi-staging. The design conditions is for a multi-stage screw compressors are the intermediate pressure, the intermediate temperature, and conservation of mass. The intermediate pressure is the typically the geometric mean of the suction and final discharge pressures. However, as the pressure transfers from the LP stage to the HP stage, there is some pressure drop in the intermediate pipe. Likewise, for temperature, as it transfers from LP stage to the HP stage, there is a temperature drop. This pressure and temperature drops are the parameters which needs to be optimized through multi-objective optimizations. Techniques such as Bayesian optimization and genetic algorithm can be employed for a multi-objective optimization where the performance parameters of screw compressors can be your objective functions. In terms of life cycle assessment, the life cycle plot of a single stage is being shown in this pie chart, whereas compared to a two-stage, if you will see the operational cost, it reduces from 68% to 51% for the same power rating and same pressure ratio compressor. Although we can see the two-stage have higher initial capital, installation and maintenance cost, their energy costs are significantly lower. When talking about the life cycle cost analysis of compressors with power ratings ranging from 22 to 315 kilowatt, the bar chart illustrates the life cycle cost difference in percentage between single stage and two stage compressor for each power rating. As the power rating increases, the percentage gain in life cycle cost savings for two stage compressors becomes more significant. As lower power ratings, such as 22 kilowatt, the life cycle cost difference is minimal, avoid 0.18%, which gradually increases with higher power levels, reaching a peak of 27.02% at 315 kilowatt. The primary reason for this trend is that two-stage compressors are generally more efficient at handling higher pressures and reducing energy consumption during operation. For higher power ratings, the energy savings from multi-stage compressors are more pronounced due to the reduction in compressor work across stages. Additionally, as power rating increases, the proportion of operating costs dominated by energy expenses grows, enhancing the economic benefits of two-stage design in these ranges. In summary, higher power ratings benefit more from multi-staging as the cost savings on energy become a larger component of the overall life cycle costs, leading to higher percentage savings for two-stage configurations. Multi-staging have their own challenges and limitations. When we talk about the multi-stage screw compressors, it is effective up to a discharge pressure of 30 bar. Beyond this, operational challenges arise due to the bending deformation of screw rotors at high pressures, which leads to the rotor deflections. Reduced lifetime of roller bearings under increased loads, elevated oil and air temperature, and finally the condensate formation in the separator vessels, which impacts the performance and maintenance. For discharge pressure exceeding 30 bar, generally compound compressor configurations, for example single stage combined with a multi-stage pistons are preferred. Multi-stage screw compressors with more than two stages are significantly not preferred due to the increasing oil to gas volume ratio in high pressure stages, which demands smaller rotors in high pressures that needs to be operated at lower tip speed, which leads to excessive wear and thereby reducing the efficiency of the screw compressors. To summarize, multi-staging offers significant benefits over single-stage compressors, especially in terms of life cycle costs and efficiency. However, it's crucial to consider the design criteria, economic implications, and operational challenges when designing the multi-stage screw compressors. Thank you for listening. With that, we conclude today's lecture. For further discussions and questions, please feel free to get in touch. Stay tuned for next week's lecture.